Have you ever felt like your shadow has a mind of its own? One minute it's super tiny, and the next it's this giant stretching all the way down the street. Well, today we're putting on our detective hats and cracking the case of the shifty shadow.
Just look at these two pictures. It's the exact same golf flag, but in one photo, the shadow is short and stubby, and in the other, it's long and stretched out. So what gives? That's the big mystery we're here to solve today.
So let's talk about these sneaky shadows. To really figure out what's going on, we've got to think like scientists, or maybe even detectives. We need to gather some clues.
Really think about it for a second. The next time you're outside on a sunny day, just watch your shadow. I guarantee it's not going to stay the same for very long. It's constantly changing.
That's right. Sometimes it's incredibly long, and other times it's so short it's barely there. And it's not just the length, right? It also points in totally different directions throughout the day. That's our first major clue in this investigation.
All right, every good detective needs a solid set of tools. And for this case, our main tool is a classic scientific experiment, the shadow stick. This is how we're going to track our shadow and gather some hard evidence.
And here's our official mission kit. The best part? It's super simple. All you really need is a sunny day, any old stick, a piece of paper, something to hold the stick up, like modeling clay, a ruler, and a marker. That's it. That's your ticket to becoming a shadow scientist.
Now for the actual mission. First, you're going to stick your, stick in a nice sunny spot. Then starting around 9 in the morning, you mark the very tip of its shadow. You're going to come back every hour and do the exact same thing. Just be sure to write the time next to each mark. You're basically creating a map of the shadow's secret journey.
Okay, hold on. Before we even think about looking at our results, I have a really important safety announcement. While you are doing this, you must never look directly at the sun. Seriously, it's incredibly bright and can cause permanent damage to your eyes. So please, be safe out there.
Okay, safety first, always. Now, once you've safely gathered all your hourly markings, it's time for the best part, analyzing the clues. This is where we start to see the pattern and really crack the case wide open.
So what did our experiment find? Well, if you connect the dots you marked, you'll see they don't make a random zigzag. They form this smooth, beautiful, curved path. This is the hidden story of the shadow's daily journey, right there on your piece of paper.
And this little chart breaks down the biggest clue of all. There's a direct connection between where the sun is and how long the shadow is. When the sun is low in the sky, like in the morning or late afternoon, the shadows get really long. But when the sun is high in the sky, around noon, the shadows get super short. It's a clear, predictable pattern.
So let's just say that one more time because it's the most important finding. The shadow is at its shortest when the sun is at its highest point in the sky. This, right here, is the key to the whole mystery. This is the smoking gun of our investigation. All right, now that you're practically a certified shadow detective, I've got a little pop quiz for you. Let's put those new skills to the test. On screen, you'll see 5 drawings of a tree and its shadow at different times of the day.
So based on everything we've just figured out, which one of these drawings shows the shadow at 12 p.m., high noon? Take a look. Got your answer? If you picked drawing number 3, you are absolutely right. It's the shortest shadow because that's when the sun is highest in the sky. Awesome job!
Okay, so we've cracked how the shadows change. We know the pattern, but the final piece of this puzzle is the biggest one of all. Why? Why does this happen day after day? It's time to reveal the secret.
The obvious answer seems to be the sun, doesn't it? We see it rise in the east, travel across the sky, and set in the west. So it has to be the sun's movement causing all this. But is what we see really what's happening?
And that question brings us to a really cool scientific idea called apparent movement. That's the official term for when something looks like it's moving, but it's actually an illusion. It's like a cosmic magic trick.
And here it is, the grand reveal. The sun isn't actually moving across our sky. The real reason for the changing shadows is us. It's our own planet. The Earth is constantly spinning on its axis, and it's our rotation that makes the sun appear to move. Mind-blowing, right? So let's just recap what you've accomplished here. By setting up a simple experiment, gathering clues, and analyzing the data, you've acted just like a real scientist. You've uncovered a fundamental truth about how our little corner of the universe works. And just look at the skills you've put into practice. You can now predict how shadows will behave. You can spot patterns in data. You understand that doing experiments more than once makes your results stronger. And most importantly, you can explain why shadows change using real scientific knowledge. Fantastic work, detective.
So, I'll leave you with one final question to keep those detective gears turning. If you did this exact same shadow stick experiment, but in a totally different country, say somewhere in the southern hemisphere, would the pattern your shadow makes be exactly the same, or might it tell a completely different story? Something to think about. Thanks for investigating with me today.